In 1853, a Scottish physician named Alexander Wood had a problem. His patient was in agony, and nothing he had was working fast enough. So he tried something new, injecting morphine directly into the skin, using a hollow needle he had recently helped design. The pain stopped almost immediately. Wood was convinced he had discovered something remarkable. What he didn't realize was that he had also just invented one of the most consequential and controversial tools in medical history. But morphine itself wasn't the accident. The accident came later, in a completely different lab, with a completely different substance, and a researcher who wasn't looking for a painkiller at all. For most of human history, pain management was a desperate business. Ancient Egyptians packed wounds with moldy bread. Medieval physicians prescribed willow bark tea, which helped, but no one knew why. By the 19th century, opium and its derivatives dominated medicine, but they came with a brutal cost. Addiction, overdose, and dependency were rampant, and physicians knew it. The race was on to find something that worked without destroying the person taking it. In 1897, that search landed on the desk of a young chemist named Felix Hoffmann, working at the Bayer pharmaceutical company in Germany. Hoffmann wasn't trying to revolutionize medicine. He was trying to help his father, who suffered from severe rheumatism and could no longer tolerate the stomach-destroying doses of sodium salicylate his doctors had prescribed. Hoffmann began experimenting with a modified version of salicylate.
The compound had existed in crude form for decades, but no one had successfully stabilized it for medical use. Hoffmann's modification made it both effective and tolerable, a combination that had eluded chemists for years. Within 2 years, Bayer was selling aspirin in powder form across Europe. Within a decade, it was one of the most widely distributed drugs in history. But here's what made aspirin genuinely strange. For most of the 20th century, nobody actually knew how it worked. Physicians prescribed it by the billions, while the mechanism behind it remained entirely mysterious. It wasn't until 1971, 74 years after its synthesis, that British pharmacologist John Vane demonstrated that aspirin works by blocking enzymes called cyclooxygenases, which the body uses to produce prostaglandins, the molecules responsible for triggering inflammation, fever, and pain signals. Vane won the Nobel Prize in Medicine for the discovery in 1982. The implications kept expanding. Researchers found that the same mechanism that made aspirin reduce pain also thinned the blood, reducing the risk of heart attacks and strokes. A drug synthesized to soothe one man's stomach became a frontline defense against cardiovascular disease. But the same properties that made it powerful also made it dangerous. Regular aspirin use can cause internal bleeding, and in children, it's linked to a rare but serious condition called Ray's syndrome.
This is, it turns out, the pattern beneath the story. Aspirin wasn't planned. It was observed, modified, and stumbled into. Its most important secondary uses were discovered decades after it was already in medicine cabinets worldwide. And the full picture of what it does to the human body is still being written. Most of the compounds we rely on to manage pain arrived through a similar combination of accident, persistence, and delayed understanding. Which raises an uncomfortable question. How many of the drugs we take today are we still only half understanding? The history of pain relief isn't a story of science conquering suffering. It's a story of humans noticing things, getting lucky, and catching up to themselves.